Hello everyone, so this is the notes for 2A for solving absolute value equations. Again, if you're going through the problems, want to check your answers, just scrub through the problem that you want to get to. But besides that, let's get started. So, the absolute value of a number represents its distance from 0 on a number line. Since distance is a scalar quantity, the absolute value of a number is always positive. If we look at a absolute value graph, we know that it is always going to be positive in both the negative direction and the positive direction. So when we are solving for absolute value equations, we're going to look for two solutions. Most absolute value equations have two solutions. One solution for the positive side of our number line or our graph, and our negative side of our number line in our graph. So let's use number one as our example. You have the notes here for solving absolute value equations, and we're going to go step by step. So our first step is to isolate our absolute value expression. What I mean by absolute value expression is whatever is inside the absolute value bracket. So when I ask you all to isolate the absolute value expression, I want you to get rid of all the numbers or all the terms outside of the absolute value brackets. So for number one, we already see that our absolute value expression is isolated by itself. But if we looked at number three, we have our absolute value expression here, but we also have this tacked on plus 17. So when we get to number 13, we will have to get rid of the 17 first before we do anything. But let's get back to number one. So number one, since we have our absolute value expression isolated, we are going to move on to step two. We're going to drop the absolute value bars and create two equations. So we're going to set what's inside of our absolute value bar to two equations. We're going to set it equal to the positive value of the other side, so our positive value 5, and we're going to set it to the negative value to indicate the negative side of our number line. So we set it equal to positive 5 to indicate the positive value of our number line, and the negative 5 to indicate the negative value of our number line. Now, step 3, all we're going to do is we're going to solve each equation. So if we solve each equation for x, we're going to add 9 for my left equation. And for my left equation, I get x is equal to 14. Now for my right equation, we're also going to add 9 to both sides. And negative 5 plus 9, well, that's the same thing as 9 minus 5. And we get the number, or x is equal to 4. So now, step 4 is to check for extraneous solutions. Well, extraneous solutions are solutions of an equation that does not satisfy the original equation. So we are talking about if you solve an equation and you get a solution of x equals a number, if this number plugged back into our regular solution, our original solution, and does not equal these same numbers on either equal sign, or besides the two sides of our equal sign, we say that that's an extraneous solution. So we are going to check for extraneous solutions by setting these x's and putting them back into our original equation. So for x is equal to 14, we're going to plug that back in. And whenever we substitute anything back in, we're going to put parentheses around it. So 14 minus 9 is 5. And the absolute value of 5 is always going to be positive. So we're going to get positive 5 is equal to positive 5. Since we have the same number on both sides of the equal sign, we know that x is equal to 14 is a solution for us. Now we're going to do the same thing, but instead of x is equal to 14, we're going to set it to x is equal to 4. So x is equal to, so instead of putting x, we're going to do 4 minus 9 is equal to 5. Now we have 4 minus 9, we get negative 5. The absolute value of negative 5 is equal to 5. And the absolute value of negative 5 is just 5. So we get 5 is equal to 5. Since that also works, we know that x equals 4 is the solution. So here we will have two solutions. X is equal to 14 and x is equal to 4. Now let's move on to number 2. Step 1, we have to make sure that our absolute value expression is isolated. Since we have nothing, we indicate our absolute value expression is absolute value 2k plus 7. We have nothing on the outside or on the same side as this absolute value expression. We know that it is isolated, so we can move on to step 2. We're going to split it up into two equations. One for the positive, so positive 3, and one for the negative side, so negative 3. Now we're going to solve for k. We're going to solve for a variable. We're going to subtract 7 on both sides. And we get 4 is equal to 2k. Now we're going to isolate our k, divide both sides by 2, and we get k is equal to 2. Oh, I messed up here. 3 minus 7k is negative 4. So negative 4 divided by negative 2 is negative 2. My bad, y'all. Now we're going to do the same thing. We're going to subtract 7 on both sides. And we get negative 3 minus 7 gives me negative 10 is equal to 2k. Divide both sides by 2. And we get k is equal to negative 5. So now we're going to plug these k's back into our original equation. And we're going to get 3 is equal to the absolute value of 2 times. We're going to plug in k equals negative 2 first. Negative 2 plus 7. Negative 2 times negative 2 is negative 4 plus 7. And 7 minus 4, negative 4 plus 7, is equal to 3. The absolute value of 3. Well, the absolute value of 3 is just 3, so we get 3 is equal to 3. This works, so k equals negative 2 is not an extraneous solution. So we know that k equals negative 2 is a solution. Now we're going to check for k is equal to negative 5. Remember, 3 is equal to the absolute value of 2. Plug in negative 5. 2 times negative 5 is negative 10. And negative 10 plus 7, we get the absolute value of negative 3. Absolute value of negative 3 is just 3, so we get 3 equals 3. And we know if that works, we know that k equals negative 5 is also a solution. So again, we have two solutions. So moving on to number 3. We want to make sure that we have our we are isolating our absolute value expression. So, like I said before, we look for our absolute value expression and see if there's anything outside of that absolute value expression. Well, there is this plus 17 right here. That means we have to get rid of this plus 17 before we do step 2. To do that, we are going to subtract 17 on both sides. Since I didn't do anything to my absolute value expression, I'm going to just bring it down. And 23 minus 17 gives me 6. Now that my absolute value expression is isolated, I can now move on to step 2 and set my absolute value equation to the positive and to the negative. Now I'm going to solve for y for both my equations, starting with my left. I'm going to add 1 to both sides, and I get y is equal to 7. For my right equation, I'm going to add 1, and I get y is equal to negative 5. Last but not least, we're going to replug y into our original equation. So we can plug y equals 7 back into this equation and y equals negative 5 back into this equation, and that's perfectly fine. However, I can also plug this y into this equation right here, and this y into this equation right here. This equation and these two equations are the same exact equations. The only difference is that we simplified it to isolate our absolute value expression. This equation and this equation are not the same as this equation right here. So when we are plugging in back y, we want to make sure that we're plugging y back into our original equation with our absolute value. We have to make sure that we're plugging it back in with our absolute value. So to make life easier on me, I'm going to plug y equals 7 and y equals negative 5 back into this equation right here instead of plugging it back into this equation. If that is too confusing, just remember that you need to plug it back into our original equation, and if plugging it back into here makes it too complicated, just plug both of these back into our original. But that being said, I'm going to plug our y's into our original equation. I'm going to do 7 minus 1 is equal to 6. 7 minus 1 is 6, so the absolute value of 6 is equal to 6. That just means 6 equals 6, so I know that y equals 7 works. Plugging in y equals negative 5, I'm going to get absolute value of negative 5 minus 1, and negative 5 minus 1 is negative 6. The absolute value of negative 6 is just 6, and we get 6 equals 6 again. This works. So we know that y equals negative 5 is a solution. All right, moving on to number 4. So remember that we want to isolate our absolute value expression. That means we have to make sure that everything on the outside of our absolute value expression is dealt with before we move on to step 2. Well, we have this 3 on the outside. This is 3 times the absolute value m plus 8. Remember that we do not want to distribute. If we distribute, usually our parentheses drop, but we can't drop our absolute value expressions, or we can't drop our absolute value brackets because they hold a special property. So you are not allowed to distribute to get rid of that 3. Instead of distributing, we want to do the inverse of the operation between 3 and this absolute value. Well, the operation between 3 and its absolute value is multiplication. So to get rid of multiplication, I want to divide. Since I want to get rid of 3, I'm going to divide by 3. These cancel out and become 1. And whatever I do to one side, I'm going to do to the other side. 39 divided by 3 is just 13. And we get the absolute value of m plus 8 is equal to 13. Now we can create our two equations, and we're going to get m plus 8 is equal to 13, and m plus 8 is equal to negative 13. We're going to solve for our variable once again. Starting with our left side, we're going to subtract 8 on both sides, and we get m is equal to 5. Then we are going to do the same thing here. I'm going to subtract 8 onto both sides. And we get m is equal to negative 21. We're going to plug back in our m to our original equation. I'm going to plug it back into this equation right here. But if you want to plug it back into this equation, that is also perfectly fine as well. So plug it back into our original equation. We get 5 plus 8 is equal to 13. Well, 5 plus 8 is 13. The absolute value of 13 is just 13, so we get 13 is equal to 13. We know that m equals 5 is a solution. We're going to plug in negative 21 in now. We get negative 21 plus 8 is equal to 13. Negative 21 plus 8 is equal to negative 13. And the absolute value of negative 13 is just 13, giving me 13 equals 13. These both work, so we know that m equals negative 21 is a solution. So now moving on to the next questions. Seeing we are going to do the same thing, and we are going to isolate our absolute value expression. Since our absolute value expression is r minus 5, we have to get rid of the 16 on the outside. Remember that we cannot distribute, so we're going to divide both sides by 16. And we end up with the absolute value of r minus 5 is equal to negative 2. Now, I want you all to think about this for a second. Can an absolute value ever equal a negative number? Remember that absolute value can never equal a negative number. It is always positive. That being said, any number that we plug in for r will yield a positive number regardless of whether or not it's negative or it's positive. Like, let's say if I said r is equal to 100 or negative 100, I get negative 100. I get negative 100 minus 5, and this gives me negative 105. But the absolute value of negative 105 is 105. So no matter how high or how negative your number is, how high your negative number is, it will always turn out to be a positive. That means r can never equal a negative 2. Or the absolute value of r minus 5 can never equal this negative 2, meaning that we have no solution. So, just to recap, if you have isolated your absolute value expression and that absolute value expression is equal to a negative number, we now know that there is no solution. All right, moving on to number 6. We have to make sure that we isolate our absolute value expression first. Some of you might see this negative 5 already and say, oh, that is no solution because my absolute value cannot equal a negative number. But we still have this minus 11 on the same side as this absolute value expression. So we need to make sure that we isolate our absolute value expression first before we determine whether or not it's no solution. So to isolate our absolute value expression, we're going to add 11 to both sides. And negative 5 plus 11 gives me positive 6 is equal to the absolute value of 8 minus p. So now I have my absolute value expression equal to a positive number. That means there is going to be a solution, and we're going to move on to step 2. We're going to make 2 equations. One for the positive and one for the negative. We're going to solve for p, starting on my left side. I'm going to subtract 8 on both sides, and I get negative 2 is equal to negative p. And to get rid of this negative number, I'm going to divide by -1. Since a negative times a negative is a positive, since I want to get P to be a positive, I'm never going to ask you all to find negative P. I'm always going to ask you all to find positive P. So I divide by -1. Whatever I do to one side, I got to do to the other. So I get 2 is equal to P. Now we are going to move over to the right equation. We're going to subtract 8 one more time. And -6 minus 8 gives me -14 is equal to negative P. Remember that I'm only asking you all to change P into a positive. I'm not asking you all to change -14 or -2 to a positive. That just happens because of coincidence. So I'm going to divide by -1 onto both sides to make P positive. And we get P is equal to positive 14. Now I'm going to plug these back into my equation. I'm going to plug it into this equation. Again, if you want to plug it into the original equation, you can. I just feel like this is easier. So we're going to do 6 is equal to 8 minus, put our parentheses around our substitution. So we get 6 is equal to absolute value 8 minus 2. Well, 8 minus 2 is equal to 6. So we get the absolute value of 6. And the absolute value of 6 is just 6. So we get 6 is equal to 6. That means we know that 2 equals P or P equals 2 is a solution. We'll do the same thing with P equals 14. 6 is equal to 8 minus 14. Well, 8 minus 14 is equal to -6. So we get absolute value of -6. Well, the absolute value of -6 is just 6. And we get 6 equals 6. So we know that P equals 14 is also a solution. Moving on to number 7. We want to isolate our absolute value term. So we have to get rid of this -2. Well, what is the operation between this absolute value term and this -2? It is division. And how do I get rid of division? What's the inverse operation of division? It is multiplication. So to get rid of this -2, I'm going to multiply by -2. Whatever I do to one side, I'm going to do to the other, and I get the absolute value of y minus 10 is equal to, these two cancel out, and -6 times -2 is positive 12. Now I'm going to create my two equations. I get y minus 10 is equal to 12, and y minus 10 is equal to -12. Solve both my equations. We start with my left again. I'm going to add 10 to both sides. And I'm going to get y is equal to 22. And for my right equation, I'm going to add 10 to both sides. And -12 plus 10, I get y is equal to -2. I'm going to plug these back into my equation to check for extraneous solutions. Absolute value of 22 minus 10 equals 12. Well, 22 minus 10 is just 12. And the absolute value of 12 is just 12. So I get 12 is equal to 12. Y equals 22 is a solution. Now I'm going to do the same thing, but with y equals -2, I get absolute value of -2 minus 10. -2 minus 10 is equal to -12. And the absolute value of -12 is just 12. So I get 12 is equal to 12. So y equals -2 also works. Same deal for number 8. I want to get rid of this 9. The operation between the absolute value expression and 9 is division. So I'm going to multiply to get rid of a division. I'm going to multiply 9. And I'm going to multiply 9 to the other side. So I end up with the absolute value of 3a plus 12 is equal to 0. So Now I'm going to create my two equations, and I'm going to end up with 3a plus 12 is equal to 0. And 3a plus 12, well, negative 0 is just 0, so we're also going to set this equal to 0. You all see that this is going to be the same equation. We're going to subtract 12 onto both sides. And we get 3a is equal to negative 12. Divide both sides by 3. And we get a is equal to negative 4. Same thing over here. Since it's the exact same equation, we're going to do the exact same thing. And we get a is equal to negative 4 as well. Oops, not negative 14. Negative 4. You see that a is equal to negative 4 on both sides, or both on the positive and the negative side. So that means we're only going to end up with one solution. We're only going to end up with the solution a is equal to negative 4. But we need to make sure that this is not an extraneous solution. So we're going to plug it back into our original equation. We have 3 times negative 4 plus 12 is equal to 0. 3 times negative 4 is negative 12. Negative 12 plus 12 is equal to 0. So we get the absolute value of 0 is equal to 0. And the absolute value of 0 is just 0. So we get 0 equals 0. This works. So that means we have one solution. And that one solution is a equals negative 4. So we get one solution. Now moving on to number 9. So again, we want to make sure that we isolate our absolute value expression. Now we have two numbers that are on our absolute value expression side. We have this 9 and we have this minus 4. Now, y'all remember your algebra rules? We cannot subtract these together because these are separated into two terms. We have one term which is 9, and we have one term that is negative 4 times the absolute value of c plus 10. We want to make sure that we isolate our absolute value term first. So instead of combining these two, we have to get rid of this 9 and then rid of this 4. To get rid of this 9, we're going to subtract 9 onto both sides. Negative 15 minus 9 gives me negative 24. And since we didn't do anything to our other term, we get negative 4 times the absolute value of c plus 10. Now we can get rid of our negative 4 by dividing by negative 4. Since this is a multiplication, we want to do the inverse. Whatever we do to one side, we got to do to the other. And we get c plus 10 is equal to positive 6. Now we can create our two equations. We get c plus 10 is equal to 6, and c plus 10 is equal to negative 6. On my left side, I'm going to subtract 10 on both sides, and I get c is equal to negative 4. For my right equation, I'm going to subtract 10 again, and I get c is equal to negative 16. We're going to plug this back into my original equation, and I get absolute value of negative 4 plus 10 is equal to 6. Negative 4 plus 10 is just 6, and the absolute value of 6 is just 6, so we get 6 is equal to 6. C equals negative 4 is a solution. Now we're going to plug in c equals negative 16. We're going to do negative 16 plus 10. The absolute value of negative 16 plus 10 is equal to 6. Negative 16 plus 10 is negative 6. So we get the absolute value of negative 6 is equal to 6. And the absolute value of negative 6 is just 6. Leaving us with 6 equals 6. And c equals negative 16 is a solution. For number 10, same deal. We want to deal with all the coefficients and all the constants on the absolute value sign first. So, or absolute value side first. So we want to deal with this 8 and we want to deal with this negative 12. Again, you cannot combine these two because these are not like terms practically. Negative 12 is a variable term because it's attached to my absolute value. While 8 does not have a variable at all, so we cannot combine these two. So we want to deal with the negative, or with the plus 8 first, not the negative 8, the plus 8. But to get rid of the plus 8, we're going to subtract 8 on both sides. So negative 16 minus 8 gives me negative 24. Since we didn't do anything to the rest to the other side, I'm going to bring everything down. Now we want to get rid of this negative 12 that is being multiplied by this, our absolute value expression k over 5, or k divided by 5. So to get rid of a negative 12 multiplied, we're going to divide by negative 12. Divide both sides by negative 12. Well, negative over negative is a positive, and 24 over 12 is just 2. So we get k over 5. The absolute value k over 5 is equal to 2. Now we're going to create our two equations. We got positive 2 and we're going to do our negative 2. Well, to get rid of a division, I'm going to multiply. Since I want to get rid of the 5, I'm going to multiply by 5. And I get k is equal to 5 times 2 is 10. And on this side, we're going to multiply by 5 again. Cancel these out. And we get k is equal to 5 times negative 2 is negative 10. We're going to plug these back into our original equation. And we get 2 is equal to absolute value of 10 over 5. Well, 10 over 5 is just absolute value of 2. And the absolute value of 2 is just 2. So we know that k equals 10 is also works, or it is a solution. Now we're plugging in negative 10 into k, so we get 2 is equal to the absolute value of negative 10 over 5. And negative 10 over 5 is equal to negative 2, but the absolute value of negative 2 is just 2, so we get 2 equals 2 again. So now we have k equals negative 10 also as a solution. So we have those two solutions again. Now, number 11 through 14 is when it gets a little bit more challenging. So if you are having problems with this, please pay attention. We want to make sure that we isolate our absolute value expression. That means whatever is inside our absolute value brackets. For number 11, we do not have anything outside of our absolute value brackets, but we do have an x on the other side of our equation. This does not change anything. All we want to do for step 1 is to isolate anything on the outside of our absolute value brackets. And since we don't have anything on the outside, we are good for step 1. Now we can move on to step 2. We're going to set our equation towards the equal side, or towards the positive side, and towards the negative side of our equation. So we get 3x minus 9 is equal to our positive side, which is just x plus 1. Now we want to make sure that we deal with the negative side of our expression as well. We get 3x minus 9 is equal to our negative side. And since we're doing the negative of this whole expression, we have to put this whole expression in parentheses. Because we are taking the negative, the negative of this whole expression. So we're going to solve for our left side equation first. We subtract x on both sides, and we get 2x minus 9 is equal to 1. Add 9 onto both sides, and we get 2x is equal to 10. Divide both sides by 2, and we get x is equal to 5. Now let's work on the right side equation. Since we have this negative, this is technically negative 1. We're going to take this negative 1 and we're going to distribute into our parentheses. And now we end up with 3x minus 9 is equal to negative x minus 1. So now we want to move all our variables to one side. We're going to add x to both sides. 3x plus x gives me 4x. So you get 4x minus 9 is equal to negative 1. Add 9 to both sides. Negative 1 plus 9 is equal to 8. So you have 4x is equal to 8. Divide both sides by 4 to isolate our variable term, or our variable. So we get x is equal to 2. Now we're going to plug these back into our original equation. Well, we didn't change our original equation at all because we didn't have to isolate a term. So we're going to plug it back into this. So we get x is equal to 5. Remember that we are plugging x into all of the times where our expression has x. So not just in the absolute value. So we get 3 times 5 minus 9 is equal to 5 plus 1. 3 times 5 is 15 minus 9. And 9 plus 1 is just 6. 15 minus 9 is just 6. So now we have the absolute value 6 is equal to 6, giving us 6 equals 6. So now we know that x equals 5 is a solution. Now we're going to plug in x equals 2. 3 times 2 minus 9 is equal to 2. Oh, I forgot to put parentheses. 2 plus 1. 3 times 2 is 6. 6 minus 9. So the absolute value is 6 minus 9. And 2 plus 1 is just 3. Absolute value is 6 minus 9. But that's the absolute value of negative 3 is equal to 3. And the absolute value of negative 3 is just 3. So we get 3 equals 3. So that also works. Notice that we have 6 is equal to 6 here and 3 is equal to 3 here, even though they are different numbers. Since plugging it back into our original equation satisfied that equation, it does not matter that I get 6 is equal to 6 when I plug in x is equal to 5 and 3 is equal to 3 when x is equal to 2. As long as when you plug it in, we get the same number on both sides of the equal sign. So now let's move on to question number 12. We're almost done. We want to isolate our absolute value expression. So we're going to deal with this 2 that's being multiplied by absolute value expression. So to deal with the multiplication, we're going to divide. So we're going to divide by 2 onto both sides. Now I get h plus 8 is equal to 14 divided by 2 is 7. So I end up with 7h. And now that I isolated my absolute value expression, I'm going to split it up into 2 equations. We get h plus 8 is equal to positive 7h. And we get h plus 8 is equal to negative 7h. And you don't have to add the parentheses for this, but I want to get into the habit of putting parentheses around expressions if needed. So I'm just going to put it in parentheses as well. So now dealing with the left side equation, we're going to move our variables over to one side. We're going to subtract h onto both sides, and I get 8 is equal to 6h. Divide both sides by 6 to isolate just our variable, and we get 8 over 6 is equal to h. Well, this can be simplified to 4 over 3 is equal to h. Now we have the other side. Negative times 7h just gives me negative 7h, and h plus 8. We're going to add, or we can add 7h, or we can subtract h. It doesn't matter what you do. I'm going to subtract h on both sides. Negative 8 is equal to negative 8h. Divide both sides by negative 8. And I get h is equal to negative 1. Now we're going to plug these back into our original equation. I'm going to plug it back into this equation right here. So we get h, or we get 4 over 3 plus 8 is equal to 7 times 4 over 3. Well, to add a fraction and a whole number, I want to make this into a fraction, and I want to make sure that we have the same denominator. Well, the common factor between 3 and 1 is 3, so I'm going to multiply both the top and the bottom by 3. So now I get the absolute value of 4 over 3. 8 times 3 is going to be 24. And 3 times 1 is just 3. 7 times 4 is going to be, so when we're multiplying fractions and a whole number, we also want to make this, our whole number, into a fraction. We're going to multiply our numerators together and multiply denominators together. So 7 times 4 is 28, and 1 times 3 is 3. So now we get 24, or 4 over 3 plus 24 over 3. That can now combine to 28 over 3. And the absolute value of 28 over 3 is just 28 over 3. So these two both match on either side. Even though they're fractions, they are still the same number. So we know that h is equal to 4 over 3 is one of our answers. Now we have h is equal to negative 1. We're going to substitute negative 1 in. So we get negative 1, and put parentheses around that. Negative 1 plus 8 is equal to 7 times negative 1. negative 1 plus 8 is 7, and the absolute value of 7 is just going to be 7. And then 7 times negative 1 is negative 7. So we get 7 is equal to negative 7. Well, 7 does not equal negative 7. That is never true. 7 is supposed to equal 7, and negative 7 is supposed to equal negative 7. So since we have two different numbers on either side of the absolute value sign, these do not equal each other, and that means h is equal to negative 1 is an extraneous solution. So that means we are only going to have one solution, and that one solution is h is equal to 4 over 3. Now, last two. These two are a little bit long, so bear with me. You all can do it. We want to make sure that we isolate our absolute value expression. Well, to isolate our absolute value expression, we need to get rid of this minus 5n. So to get rid of this minus 5n, we're going to add 5n to both sides. Now I get the absolute value of 8 minus 2n is equal to 5n plus n gives me 6n plus 2. Now that my absolute value expression is isolated, I can now split them up into two equations. I get 8 minus 2n is equal to 6n plus 2, and 8 minus 2n is equal to, since it's an expression, we want to put our negative on the outside and do the negative of our whole expression. So 8 minus 2n, we're going to deal with our left side equation first. We're going to add 2n to both sides. And we get 8 is equal to 6n plus 2n is equal to 8n plus 2. Subtract 2 onto both sides to isolate our n. And we get 8n is equal to 6. Divide both sides by 8. And we get n is equal to 6 over 8. Well, 6 over 8 simplified is 3 over 4. So we get n is equal to 3 over 4. Now we want to deal with our right side equation. We're going to distribute this negative into our expression. So we get 8 minus 2n is equal to negative 6n minus 2. We're going to add 6n to both sides because we want our n's always to be positive. 8 or negative 2n plus 6n gives me positive 4n. And we're going to subtract 8 onto both sides, giving me 4n is equal to negative 10. Divide both sides by 4, and we get n is equal to negative 5 over 4. Or not negative 5 over 4, negative 5 over 2. Since we simplify the top and the bottom by 2 with a common factor of 2. So now we are going to put these back into our original equation. We're going to start with 3 over 4. The absolute value of 8 minus 2 times 3 over 4 is equal to 6 times 3 over 4 plus 2. Negative 2 times 3 over 4. We're going to make sure that we make our whole number into a fraction. And we get 8 minus 2 times 3 is 6. 1 times 4 is 4. Is equal to 6. Well, 6 times, make this also into a fraction. 6 times 3 is 18. 1 times 4 is just 4 plus 2. Now we want to add. We're going to put this over 1. Well, the common factor between 1 and 4 is 4, so we're going to multiply both the top and the bottom by 4 to get the common denominator. And I get 8 times 4 is going to be 32 over 4 minus 6 over 4 is equal to, same thing here, we want to put this over 1 to make it into a fraction. And to get the common denominator, we're going to multiply both the top and the bottom by 4. We get 18 over 4 plus 8 over 4. 32 minus 6 is going to be 26 over 4. And 18 plus 8 is going to be 26 over 4 as well. So now the absolute value of 26 over 4 is just going to be 26 over 4. So we get 26 over 4, we get the same number. So we know that n is equal to 3 over 4 works. Now, we're going to plug in n is equal to negative 5 over 2. And we're going to do this in a different color. So we get the absolute value of 8 minus 2 times negative 5 over 2 is equal to 6 times negative 5 over 2 plus 2. So now we're going to multiply with our fractions. 2 times negative 5 is going to be, or negative 2 times negative 5 is going to be positive 10. So we get 8 plus 10 over 2 is equal to 6 times negative 5 is negative 30 over 2 plus 2. Now I get 10 over 2 is just 5, so we get 8 plus 5 is equal to negative 30 over 2, just gives me 15, or negative 15. So negative 15 plus 2. 8 plus 5 is going to be 13. And negative 15 plus 2 is going to be negative 13. 13, absolute value of 13 is just going to be 13. And I get negative 13 is equal to 13. We know that those two are not the same number. So this one does not work. That means n equals negative 5 or 2 is not a solution. It's an extraneous solution. So we only have one solution, and that one solution is n equals 3 over 4. Last but not least, let's do number 14. So we want to make sure that our absolute value expression is isolated. It is isolated. There's nothing on the outside, so we are good on that. So now we're going to create our two equations. We get the positive side of our number line. So we're not going to change anything. So we get negative 4w minus 2 is equal to 6w plus 20. This is practically doing, remember when we're doing the positive side, we're just multiplying it by a plus. Well, multiplying plus is just plus 1. 1 times negative 4 is negative 4w. And 1 times negative 2 is just going to be negative 2. So that's how we get that positive side. Now we're going to do the negative side. Instead of doing plus 1, we're going to do minus. So negative, the expression negative 4w minus 2 is equal to 6w plus 20. Now we're going to solve our equations for w. We're going to add 4 on both sides to keep our w's positive, and we get negative 2 is equal to 10w plus 20. Subtract 20 on both sides. Negative 2 minus 20 is going to be negative 22 is equal to 10w. Divide both sides by 10. And we get w is equal to negative 22 over 10 simplifies to negative 11 over 5. Now we're going to distribute our negative into our expression. So we get positive 4w plus 2 is equal to 6w plus 20. Now we're going to subtract 4w on both sides, leaving us with just 2 is equal to 6w minus 4w is 2w plus 20. Subtract 20 on both sides to isolate our variable, and I end up with negative 18 is equal to 2w. Divide both sides by 2, and I end up with w is equal to negative 9. Now we're going to plug these back into our original equation. We're going to start with w equals negative 11 over 5 first, and we're going to plug it back into our original equation. So we're going to plug negative 11 over 5 into w, so negative 4 times negative 11 over 5 minus 2 is equal to the absolute value of 6 times negative 11 over 5 plus 20. Negative 4, we're going to make this into a fraction. Negative 4 times negative 11 is positive 44. 1 times 5 is just 5. Minus 2 is equal to negative 6 times negative 11 is negative 66. And 1 times 5 is just going to be 5 plus 20. We're going to now make these into fractions so that we can combine these together. The common factor between 5 and 1 is going to be 5, so we're going to multiply 5 onto both sides. And the common factor between 5 and 1 here is also 5, so we're going to multiply 5 by 1 and 5 by 20. So now I get 44 over 5. We didn't do anything to that. Minus 2 times 5 is going to be 10 over 5. And 1 times 5 is just 5. So now we get negative 66 over 5 since we didn't do anything to that. Plus 5 times 20 is going to be 100. And 5 times 1 is just 5. So now we're going to combine our fractions together, and we're going to do 44 minus 10. That's going to be 34 over 5. And negative 66 over 5 plus 100 over 5 is also 34 over 5. The absolute value of 34 over 5 is just 34 over 5. So we get 34 over 5 is equal to 34 over 5. So now we know that w equals negative 11 over 5 is a solution. Last but not least, we're going to plug in negative 9 for w. So we get negative 4 times negative 9 minus 2 is equal to the absolute value of 6 times negative 9 plus 20. Negative 4 times negative 9 is going to be positive 36 minus 2. And 6 times negative 9 is going to be negative 54 plus 20. 36 minus 2 is going to be 34. And negative 56 plus 20 is also going to be negative 34. But the absolute value of negative 34 is just positive 34. So we get 34 is equal to 34, and we see that W equals negative 9 is also a solution. So that's it. If you have any questions, look back. I know I went a little fast at the very end, but this should be all the notes for 2A. I hope you all have a great day.